Thanks for having me. Like you mentioned, my name is Nick Greuter. I'm with Kova Engineering. I'm a professional engineer there, and I just want to talk to you today about tower crane certification following a misadventure. So for those of you that don't know, Kova Engineering has been involved in the inspection, repair, and certification of cranes and hoists for over 30 years. Kova employs a team of highly trained and experienced crane inspectors, non-destructive testing technicians, working under the direct supervision of professional engineers. Our diverse team of civil, mechanical, and metallurgical engineers ensure that we always have the expertise needed to help keep your crane operating safely. We also specialize in the structural design of tower crane foundations, climbing drawings, anchor stools, and other custom tower crane components. So we'll go ahead and dive right in. We're going to start with Occupational Health and Safety Regulation, Part 14, Cranes and Hoists. For those of you that don't know, the Occupational Health and Safety Regulation contains all of the legal requirements that must be met by all workplaces under the inspectional jurisdiction of WorkSafe BC. This regulation applies to a crane or hoist as specified in 14.2 here, and any other equipment with a different primary function that is to be used for hoisting or lifting applications. In this regulation, it references the CSA Z248 tower crane code as well as the ASME B30.4. The important distinction between these two codes and standards are the CSA focuses on all tower cranes, where the ASME is not intended for use with tower cranes not used in construction. For this presentation, I'll focus on the regulation and the CSA code as they're most applicable to everyone in this room. I'll also point out the free OH&S regulation app, which I would recommend everyone downloads on their mobile device, and you can access the regulations from site. So we'll briefly have a quick look at some of the various types of tower cranes that you'll find on most construction sites. Here you see your hammerhead tower crane, flat top tower crane, luffing boom, and self-erecting tower crane. There can be various different types of tower crane base supports, various typical static bases as well as traveling bases. This regulation also applies to all top climbing tower cranes, which is very typical for the Vancouver area, and bottom or internal climbing tower cranes, which are more prevalent in the Greater Toronto area. So first, let's take a look at what the regulations say about inspection, maintenance, and repair. Clause 1, each crane and hoist must be inspected and maintained at a frequency and to the extent required to ensure every component is capable of carrying out its original design function. In the CSA code, you can reference exactly what that means for tower cranes. Clause 2, a crane or hoist must not be used until any condition that could endanger workers is remedied, which is specifically important to misadventures. We'll carry on. Specifically, the regulation dealing with misadventures classify misadventures into a few categories. A contact with a high voltage electrical source, a shock load, a loss of load, a brake failure, a collision or upset, or any other circumstance that may impair the safe operation of the crane or hoist. If a crane or hoist is subject to a misadventure, it needs to be evaluated by a professional engineer, inspected and repaired, and certified as safe for use. The CSA code, the only mention of misadventures they lump it in with special inspections, which are considered shock loading, electrical contacts, other misadventures, as well as repairs, alterations, or prolonged shutdown. It's important to note that anytime you're making structural alterations to a crane, it needs to be reviewed and approved by an engineer or the manufacturer. So we'll go into the first category of misadventure, contact with a high voltage electrical source. We've already touched on limits of approach. In the event that you come within limits of approach and you do contact a high voltage electrical source, the current will travel through the tower crane structure and must be assessed by an engineer. Important to note is the tower structure must be grounded, not only the electrical components of the tower crane. And it's also important to remember that lightning strikes would be considered a high voltage electrical source. Here you can see a crane that the rigging contacted some power lines. On the left-hand side, you can see arc marks on the rigging itself. And on the right-hand side, you can see some master links showing arc marks as well. In this situation, all the rigging would be removed from service and destroyed. Here you can see the same crane and the contact from the master links to the load hook. On the left is the arc mark before it's been cleaned up, and on the right you have it after it's been kind of blended out. You can see the heat affected zone, which will change the metallurgical structure of the material, and again needs to be assessed by an engineer and returned to service or repaired. This is that same crane's load block and hook after disassembly. You can see the heat affected zone on the load block plates as well as the sheave pins. So again, all of these components would need to be removed from service and replaced, and likely the load line replaced as well. So you can imagine how expensive that can get.
Is this AC or DC?
I'm not sure. On a separate crane, it's important to remember that a power line contact can also affect the slewing bearing. In a situation where you have the current going through your slewing bearing, you can result in essentially welding of the bearings and races, which will significantly reduce the service life and compromise the safe use of the crane. The next category we're going to discuss is shock load. So to define a shock load, it is a condition where the equilibrium of a system is disrupted by a sudden acceleration or deceleration, or by a sudden change in the direction or magnitude of a velocity vector. I've included a sample problem, but don't worry, there won't be a test at the end of this. The main point of that is to show that just over a 6-inch drop, you can have a load increase of 450%. So it can be quite significant. The next category we're going to discuss is loss of load, which again is a type of shock load that will send that loading through the entire tower crane structure. The OH&S regulation gives us some guidelines on safe lifting, which you can read here. I won't bore you and read every note, but clause number 3 is specifically important, that a load must be secured during a lift to ensure that all or part of the load cannot be dislodged. Some possible causes are incorrect rigging technique, rigging failure, load line failure, or hook failure. You can see the failed load line on the right there, so you can imagine what kind of force it takes to fail a load line that size and how that would affect the rest of the structure of the crane. The next category is brake failure, which I would expand to any mechanical component failure that may compromise the safe operation of the tower crane. Now, if this occurs while hoisting a load, again, a shock load will travel through the entire tower crane system. This type of failure will likely require a structural inspection and also a mechanical and controls inspection performed by the tower crane owner's personnel. It's important to note what the OH&S regulations state about modifying any structural, mechanical, or controls component of a tower crane. So clause number 2, if a modification that affects the rated capacity or safe operation of a crane or hoist is made to its structure, to one of its mechanical components, or to its control systems, the crane or hoist must be assessed, have its rated capacity adjusted, and be certified for use by either the manufacturer or a professional engineer. Now, that's specifically important because, as Story mentioned, whether it's an aircraft or a tower crane, when you're making modifications to the manufacturer's design, you're changing the pedigree of that equipment. For better or for worse, it needs to be reviewed and approved. Our next category is collision or upset. Again, the OH&S regulation gives us some guidelines on what a collision is. So a load must not contact a structural member of a crane or hoist, and a structural member of a crane or hoist must not contact any building, bridge, other crane or other structure, fixture, or improvement. Now, if this does occur, it needs to be inspected under the direct supervision of a professional engineer and repaired in accordance with that engineer's recommendations. Some common examples of this type of collision would be a load block contacting the tower crane mast or structure, the load line contacting another crane or structure, or the mast contacting a slab edge, rebar, or formwork. Lastly, we have any other circumstance that may impair the safe operation of the crane or hoist. Some examples of this would include damage during transportation and direction, two blocking, running wire rope contacting the tower crane structure, exposure to extreme heat, side loading of the jib, and a prolonged shutdown. So here you see a couple examples of damage that can occur during transportation or erection. As opposed to Ontario, BC does not require a post-erection inspection in the guidelines. So it's very important that the erectors know that they need to report any damage to the structural engineer of record to either be approved for service or repaired as required. On the left, you have an example of two blocking in which the load block is raised past the upper limits of a crane, damaging the trolley, load block, or perhaps the load line. Again, this is a situation that would need to be assessed by a professional engineer and either repaired or judged suitable for service. On the right side, we see a running wire rope contact with the tower crane structure. As you can see, it doesn't take long for a wire rope to work its way through a structural member of a crane. So again, this would all need to be evaluated and repaired by a professional engineer. One other note on the wire rope contact is sometimes this can occur if sheaves are not installed correctly during erection. Here we have an example of a tower crane that's been exposed to extreme heat. You can also see that there's propane tanks sitting right next to the tower, so that's probably not a good thing either. But in this situation, again, exposure to extreme heat can change the metallurgical structure and needs to be assessed by a professional engineer. There's a lot of stuff to go through on this slide, so I'm going to go through it quickly, but we're going to dive into each one of these areas in depth, so bear with me. Number one, the tower crane is removed from service immediately following any misadventure. The engineer of record is then provided the original certification documentation, misadventure report, and equipment logbook. The engineer of record will prepare an appropriate inspection plan, taking into consideration the nature and magnitude of the misadventure. The structural inspection and non-destructive testing will be performed in accordance with the inspection plan and under the direct supervision of the engineer of record. The mechanical and controls inspection will be performed by qualified personnel if required. The mechanical and controls repairs will be performed to return the equipment to the original equipment manufacturer's specifications. The engineer of record will provide a structural repair procedure if necessary, and those repairs will be completed by qualified personnel and inspected. Finally, the engineer of record will provide certification documentation permitting the tower crane to be returned to service, typically under its original certification, which is valid 1 year from the date of the original certification, not from the date of the misadventure. So this procedure in a flowchart would look somewhat like this. You can say that it's divided between your mechanical and controls and your structural side. So we'll go down the structural path first. Again, the tower crane owner will provide the certification documentation, misadventure report, and the logbook to the engineer of record. Based on this, that engineer will put together an inspection plan for both the mechanical and controls, if needed, or the structure. He'll pass that on to the structural inspection personnel, which can be the crane inspectors or NDT personnel, and also provide any required repair procedures to the qualified repair personnel. On the other side, the tower crane owner is responsible for providing qualified personnel to perform the mechanical and controls inspections and repairs. Once all the repairs are complete and the engineer of record is satisfied, he can issue the final inspection documentation to the tower crane owner, returning the crane to service. One important distinction between the structural and mechanical sides is the structural side is under the direct supervision of the professional engineer, and the mechanical side is under the direction of the engineer. So we'll start with the inspection plan. This is prepared by the engineer of record based on the type and magnitude of misadventure that occurred. It will outline the structural and mechanical control inspection requirements, identifying any specific components requiring inspection and non-destructive testing methods required. This may require the disassembly of certain components, load blocks, hooks, swivels, etc. It's important to note that the inspection plan will be an evolving plan based on the findings of the initial inspection. We'll go into the responsibilities of the tower crane owner. First and foremost is to remove the tower crane immediately following any misadventure, provide the documentation to the engineer of record, ensure that any known issues or concerns that may affect the safe operation of the tower crane are brought to the attention of the engineer, and ensure the tower crane is clean and accessible for inspection. They may also be required to provide personnel to operate the crane if needed for inspection, and qualified personnel to inspect and repair the mechanical and control systems. Next, we have the engineer of record, who is responsible for reviewing the documents provided by the tower crane owner, preparing an appropriate inspection plan. They will also be confirming the qualifications of the structural inspection personnel, as well as providing direct supervision of the structural inspection. They're responsible for confirming that the mechanical and controls inspection has been performed as per the inspection plan, and provide any structural repair procedures and re-inspection requirements as needed. They should also be confirming the qualifications of the structural repair personnel. After all of the inspections and re-inspections have been performed, they can provide the final certification documentation, and the tower crane may be returned to service. The structural inspector is responsible for performing the structural inspection in accordance with the inspection plan provided by the engineer of record, as well as inspection of any structural repairs. The structural inspector shall be familiar with the equipment being inspected, all applicable occupational health and safety regulations, and all applicable codes and standards. For tower cranes, they must also be qualified to the requirements of CSA W178.2, certification of welding inspectors. The NDT technician, again, they're responsible for the non-destructive testing in accordance with the structural inspection plan and any inspection of repairs required. They must be qualified to meet the requirements of the Canadian General Standards Board 48.9712, which deals with the qualification and certification of NDT personnel. Some of the typical NDT methods that you'll find in tower crane inspection would be magnetic particle testing, liquid penetrant testing, and ultrasonic testing. These are different methods to find discontinuities in the crane or weld structure and are to be evaluated by a professional engineer. The mechanical and controls inspection personnel will perform an inspection of the mechanical and control systems only if required by the inspection plan. This isn't necessary for every misadventure, but it is based on the engineer of record's inspection plan. They should be qualified by their employers as being competent to inspect and repair the mechanical and control systems. They should also be familiar with the equipment being inspected, all applicable health and safety regulations, and all the codes and standards. The most important note is they must seek approval from the original equipment manufacturer or the engineer of record for any modifications to the mechanical and control systems of the equipment prior to the work being performed. The structural repair personnel are responsible for only performing repairs in accordance with a repair procedure provided by the engineer of record or the manufacturer. All welding on a tower crane should be done in accordance with the CSA W59, welded steel construction, and W47.1, which is certification of companies for welding of steel. So, to briefly summarize, you're going to immediately remove the tower crane from service following any misadventure, provide the current certification, misadventure report, and logbook to the engineer of record. The structural and mechanical and controls inspections are performed as per the inspection plan. All the repairs are completed and inspected as required by the engineer of record. And finally, the engineer of record will provide the final certification documentation, and the tower crane may be returned to service. So here's some of the sources: CSA and the ASME tower crane codes, occupational health and safety regulations, the FEM design guide for hoisting appliances, and the EGBC professional practice guidelines that, as Stuart said, will be implemented late this year. Thank you for your time. I appreciate you guys having me, and thanks to BC Crane Safety and WorkSafe for putting on this event. Now, if you have any questions, I'd be happy to answer them.
So in your
Yep.
experience from the time that the shock load is reported and the crane is shut down, what's a typical shutdown period for the factory?
From the time it was, so for those that can't hear, after a shock load incident, what's the turnaround for a typical reinspection? Is that correct?
Yeah.
That would depend on the magnitude of shock load. It's very different if you're picking a max load at the tip or if you're picking 10% of your load in close to the tower. So it would be situation by situation, and it would also depend on the inspection findings. Obviously, if there's damage to the structure and repairs that need to be done, that's going to delay that by quite a bit. So it can be anywhere, to answer your question, anywhere from a day to weeks if there's repairs to be performed. Yeah.
If the Z248-2008 is implemented, do you anticipate much change in the procedure as we're now complying to?
So if the CSA standard is updated to the 2008, will there be changes to the inspection procedure following a misadventure? I wouldn't anticipate any changes. I would have to read through the code a little bit more in depth, but I would estimate that it follows a very similar path. If that's all I have for you. So thanks again for having me.